Let's see another practice problem that involves differentials. The base radius and height of a right circular cone are measured as 10 centimeters and 25 centimeters, respectively, with a possible error in measurement as much as 0.1 centimeters in each one of the height and the radius. We are asked to use differentials to estimate the maximum error in the calculated volume of the cone. So the volume of the cone, first of all, is given by V equals to pi times r to the square times h over 3. And the error, the possible error that we can make is, let's call that error dV. So now we have two parameters here, the radius and the height. So the differential dV would be equal to the partial derivative of v with respect to the radius, r, times dr times the error in the measurement of the radius, plus the partial derivative of the volume with respect to the height, let's call that h, times the error that we make in the height. So the partial derivative of v with respect to r would be just equal to 2 pi r times h over 3. And the partial derivative of v with respect to the height would be equal to pi r squared over 3. So substituting those in the differential dv, we'll get 2 pi r h over 3 times dr, and then plus pi r squared over 3 times dh. And we're given that dr is equal to dh, and this is equal to 0.1 centimeters, and also that the radius r is equal to 10 centimeters, and the height is equal to 25 centimeters. So dv would be equal to 2 times pi times the radius, which is 10 centimeters, times the height, which is 25 centimeters, divided by 3, times the error in measurement, which is 0.1, so the dr is 0.1, and then plus pi times r squared, which is 10 to the square, divided by 3, times the error in the measurement of the height, so dh, which is 0.1. So that will give us, from the first term, we'll get 50 pi over 3, and from the second term, we'll get 10 pi over 3, and that gives us 60 pi over 3. Therefore, if the differential dV would be equal to 20 pi in centimeters squared, and that is approximately equal to 63 centimeters squared.